Hello, dear people. Today I'm going to try to build a low-voltage tube tester. I was looking at this video right here where we
Very
have
cool.
something, well, video will soon be showed.
All
So
right,
now you get
back at
commercials
home.
of commercials. Anyway, this is Usagi Electric. So he is building blah blah blah. I'm building this stuff that tests a vacuum tube at 24 volts. Blah 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 blah. He says, and it's very interesting. But so I was looking here on the source codes and the schematics, and I will try to use knowledge from this project to build a tester that will test for in the range of plus minus 12 volts, which is almost the same as this one, which is based on 24 volts. Yes. So how do I do it? Well, first thing is I start up the ECEDA program, and I will start a new project. And it will be called tube tester arduino. All right, very good. And what do we do next? Well, we just sort of delete that, and we write our beautiful company name here. And we make, so we want to view white on black, of course, which is much more beautiful, objectively speaking, of course. It's not my opinion, it is the opinion of God. Anyway, so let's see here. Let's call it plus 12 volt minus 12 volt vacuum tube tester Arduino. Yeah, and let's just sort of copy what is in the things that we want to keep here, which is I'm not so sure about this. This looks like it's testing only a pentode, and which can be good, of course, but I want to test different kinds of tubes. So we'll have to do something about that. Here is an operational amplifier, which uses 6 volts plus and 10 volts minus, which is kind of strange. So we will use similar to this. We will use, but we will just power it with plus minus 12 volts, I guess. And so maybe we could start with that. I will use my own resources here, which I have in my resource project. So I don't have to think any much extra, you know. Don't think if you don't have to. So what will we use? We will use a dual op amp here. We will probably just need one, but you know, if we have to, we can use this because I don't have any single ones. So we are forced to use this one right here. And what more do we need? We need some resistors and capacitors and an Arduino board and a button. We'll skip this one because it's only for generating the negative voltage. So we'll probably not use that. So let's see, where were we? Yes, I should take this definitely into Photoshop so I can draw on it. That would be a very good idea, because otherwise I get a little bit focused. Let's see, open it, and where is it? Well, let's just see if we have recently used it. No, not really. So where can it be? Where can it be? Well, it must be here. Yes, a number. Yes, yes. Okay, beautiful. So a new layer and a pink color. So let's just start with one. Okay, didn't want to do that. So let's start with this one. It isn't too much we can do before we get the Android Nano. Wow, do you know what I see? That's very good. Didn't think I had it in this project, but that's very good. So there we have the Arduino. So then we could start to draw a little bit, sort of like, okay, we have this and we have that. And we should get our, what is it called? It's called a sort of a vacuum tube socket. Let's see if we could find any 9 or just sort of tube socket. Can't be very many of those. Let's see what we have. So we want one that has just the ones I will use most is the 9-pin kind. So these are special kinds, it looks like. And let's see if they're counting from the right direction. I'm not really convinced about these right here. So they're quite strange, all of these. Maybe this could be okay. I think we will use this one. Okay, and maybe we will also do something similar to this. You see this one, I draw this to code the pins here in the functional way that we use them. So I will try to do something similar with this one, maybe. But it shouldn't become too complicated a project now. So we have this. Let's just make this a darken layer so we can see through what we are doing here. So we have the components we need. So let's just do what exactly? Well, that's a good question. Just one moment, second window, bum. Why does it do this? I mean, a real paper doesn't really do this unless it's really wet. Okay. So we need just resistors, voltage supply connections, and one capacitor. So that's quite good. So I think we will use a standard eurorack voltage. So we get some incoming voltage in our project, which is always good to have incoming voltage. And let's see what more we can need. Yes, I said it, capacitor and resistor. So use this is always good to use. And here we have capacitor. So just paste this one here and give it the name of R1. And I'm not sure if we need these. Don't think so, but we could save 2 of them at least. But we can call these 10 and 11. That would be really good. And then this one can be there you go. Okay, so now it's time to start just copying the layout of the schematic that we had. So try to get some 2 windows thing going on. That's not too simple now, is it? No, it's not very simple at all. But if it was simple, everyone would be doing this, right? All right, so let's see. We have the positive or the non-inverting input comes as an where are the tools for this program? Okay. Anyway, here comes this one right here. So let's just okay. So we have to have everything in the correct order or else things will not work. All right, like that. And then we have one going to work around. And we have another one like that. And there, this one is going to ground. Right there. And then it goes in to the non-inverting input right there. So then we have this. Yes, it should also go somewhere. And instead of this super long line here, which I almost don't see anymore, instead of it, let's make a net flag right there. And we will see what it's called over here when it is coming in. So it's called D3. So let's call it D3 here. So this net flag is called D3. And then we can make a copy of it. Control C. And we go to the Arduino board and we connect it at the D3, just like that. Okay, very, very good. Then we take a ground connecting here and then one here. So then we're allowed to do that. Okay, beautiful, beautiful, beautiful. So now we have this, the inverting input. The inverting input is having a connection or it's having several connections, one going up and one going down. So we just do it like that. One go up and one go down. So then we have this, and this goes up and this goes down. And the one that goes down will have 2 connectors, so we can just borrow. No, we can't do that. Yes, we can. All right, just take one at a time. One going down and one going to the side like that. And they go to ground. If you want it to look more like this image, we can take these grounds and pull them really long down like this. Doesn't matter, but it's easier to make the visuals as close as possible, because then it's easier for you to find if you make anything wrong. So the values are different here. This is 4.7, 4K7, and this is 22K, 22K. I'm not really sure exactly what this does here. It's amplifying something. That's about as much as I can say. And here there is some kind of biasing also, which I don't understand, but you know, I don't know. We might have to draw this in a program that is making simulations, because I don't know what is going on here and what else will be the difference when I will put 12 volts here instead of the 6 volts that are used in the original. So we will have to see about that. Yes, and so here they are having, this line goes to positive voltage and this line goes to negative voltage, but in my layout it's like this, so I have to put like this, negative voltage and positive voltage, but it's actually the same thing going on. It's exactly the same, except for that we are using different values, and that is so everything is actually different. Okay, but who cares, you know? So then we have this one is going to this, and this one is going to that, and this one is going here, and this one is going there, and this one is going there. So we're sort of ready. Let's see, where were we? Yes, we were sort of right here. Okay. Wonder why I made a copy of that, but you know, can't be too sure about anything these days, so it doesn't matter. And so what do? Well, we're gonna go like this, because we can, you know, because we can do that. All right, so bam bam, and a little line going out like here. Beautiful. So now it's time to do a little more studying here. So we are having a little resistor right there. Okay, beautiful, 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 beautiful. And now this pentode is set up like a triode, I would say, because it's not using, it's actually only using, let's see here, what it's actually doing is like this. Please allow me to demonstrate my immense knowledge about this stuff right here. So you see, here is the ground, or the well, we can call it ground because it's grounded, but it's not ground. It's called something sort of anode or cathode or something. Anyway, doesn't matter, because this is connected to this one right here. So this one is actually not being used, and this one is connected to to right here. So it's also not really being used. It's just a copy of this, but with another resistance connected to it. So the only thing that matters is that this goes to this one right here, and it is called the what's it called? Yes, it's called a grid. Grid. So this is the grid. It's sort of the control thing. So we could actually sort of ignore these for now. Let's see here. Let's see if I do like this. And I do like this. And now we have just one triode here. Yes, and then we should just try to, we can also ignore this for now. Let's see, we can ignore this because it's just a heating. So we could ignore this, this, and that. So what more do we have to think about? Well, the only thing we need to think about is that this is the grid. So we can make something here that we call the letter G. So now I need some more Photoshop stuff. Please, Photoshop, where is your stuff? Please, Photoshop, show me your stuff. Well, Photoshop is sort of, there you go, beautiful. So where were we? We were here, yes. So I want to make this a little bit larger like that. So that's the grid. And now I have to double check things because I'm not super good at this. But if we just write something like this, pinout, and we look at the pinout for such a thing, we see that we have, so this is it is called a pinout for a double triode. And what we need to know now is what is the name of the ground? Well, the name of the ground is K or C, which is cathode or cathode. So we just call it C. And then we take one more that we call anode, which is the sort of positive. So then we have yes, let's just make these nets in our layout here, which will help us a little bit on the way, but not really. So we just call this G, and then we have the letter A and the letter K. I don't remember which was which now. So the A is the above and C is in the cellar. Very good to remember. So, and according to this layout, we should have 100K right there, and above here we should have 24 volts and 33K. And here's the thing, I'm not really super aware of how to do this, but because I will use not ground here, but But instead, you see here is a ground, but I will use negative voltage here. And I don't actually know how that will affect anything here. Maybe only this voltage divider here will be different because, you know, it will be because here we are trying to take this signal here and scale it using ground and using positive 24 volts, but what I will have is plus 12 here and minus 12 here, so the scaling here must be different. Okay, so that doesn't matter so much now, I think, but you know, we have to see. We have to see. So I think we have to actually do some simulations in this program. So we have to redraw everything once more time, which is so funny. Yes, I really think it's so much funny. Yes, yes, yes. Okay, so we have resistor. But I'm so much faster at drawing in this program because I've done it so many times. Yes, and here we should actually maybe, what should we actually, we should have 6 here and we should have minus 10 here, which are very strange values, but it doesn't matter because that's how the guy in the internet did it, you know, so we have to do it also. So let's see, 12. No, not 12 was it? What was it in the original? Let's see. Original. Okay, it was 6. So my idea is to make one simulation with the original numbers and then one simulation with my values and then adjust accordingly until it gives the same value or the same results. So, and then we had something called 22 here. Yeah, we could borrow this one because it's not being used. You should never waste anything, so please remember to recycle components. 22 right there, and what do we have now? Well, we have a something like this, and then 100, yes. 100 right here. So exactly what is it that I want to know now? Yes, I want to know the value that comes here. And if we follow the line here, from here, it goes here, 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 and to a digital output on the nano, which will be 5 volts. So therefore, I will take a, what's it called, input of a DC. Let's see, where is it? We might as well use a square wave, it doesn't matter. Just as long as it goes from 0 to 5 here, so we must do like that. All right. So we should watch here and we should watch here carefully to see what's happening. Okay, so let's see, stack. And we want to see properties called maximum peak, maximum negative peak, maybe average. Okay, that's good. Okay, properties show peak value, negative peak value, and average. Yes. So we are already having some problems here. Why is that? Well, we have to just double check. Is everything all right here? Are we doing everything that we are supposed to do? I mean, we should have some value here, shouldn't we? Yeah, so everything looks like it's not working. What did I do wrong here? What did I do wrong? Is this really that value? How can it be this value? It's not fair, you know. It's not fair. Okay, so what the fuck is going on? Because it is a digital value going out here, isn't it? And what is this? Could it be some kind of what exactly are you doing? Well, I have to look in the code maybe to see if this is used as a pulse width modulated outgoing signal or what. So let's see if we have to do that by doing something like this. This should be the voltage coming from the frequency coming from Arduino if you use a pulse width modulated signal. So what value do you get here? Okay, and if I change the duty cycle here, do I get another value? Yes, we get another value up there, which is sort of what we would want, I think. But what do we get here? That's what I want to know. View in new scope. We are still getting a minus 10, which is not good. It is not good at all. So what did I do wrong? Yes, now I see what I did wrong. I did this. This is connected wrong. It's supposed to be here. Yes. Okay. So, like this. Okay. But nothing changed. Yes, because, this one has to be right there. All right, so now we are getting a value here. And the value is negative 9 volts, which is good, I think. So let's see if we put 90% here, what will happen? The voltage changes and goes up. So must make some kind of table here. So at 90%, we get a grid of voltage of 5. of 5.99. All right, let's call it 5.9. And if we take, if we take a duty cycle of 50, what voltage do we get? So we get negative 1.5. 50% GB minus 1.5. And finally, we take, what was that? We take 10 and we get exactly what? We get negative 9.1. Okay, so let's try to change some things, but try to get the same value. And yes. Minus 9.1. All right. Okay, I will do like this. I take everything here and I make a copy of it and I move it down here. And then I change one thing at a time. So first we change this one, but we also have to change that one because they're the same. And maybe we should also change this one. So we change everything at once, and then we try to get the same values here. So let's see, where are we now? Yeah, that looks the same. At 10%, we get 9 minus 9.15. Maybe we should change that then. So 9.15. Okay, and when we take 50%, what do we get? Okay, we are not getting anything to change. That is a big problem. No, wait a minute. I'm stupid. Yes, you are stupid. So we have to use this one because... So erase and rewind. 10%. Or was it 90%? No, it's 10%. So let's run it and see. All right, so we are getting much too small value, which means something that I'm not really sure about, but let's see here. If we do something like, if I was to change this value, would it change anything? Yes. There is where we can change everything. Yes, so I have to change it to maybe 30. No. Maybe 28. Yes. 29. No. How can this actually be? This is very, very strange for me. Very, very strange. Okay, so let's see here. So we have a lot of things going on at the same time here. So that's why I am getting a little bit confused. So let's just test. Let's just do like this then. 33, 39, So everything is going upward, but I want it to go downward. So what do? It stops going up. Doesn't it stop? No, it keeps going. Okay, that's good. So please go to 9. Okay, so it's somewhere maybe 24. Something like that. Yes. So we will most likely put a trim pot here or something to make this thing actually work as intended. But it doesn't really matter so much to get the values right, because the only thing I will check is things against each other. I mean, one tube against the other tube. So let's just say that we have this very close now, so it's close enough, I would say. 8.888. Oh, that's so beautiful. Do you see the symmetry there? Okay, sort of like this. And then what do? Yeah, we'll change here to see if it actually is working all over the spectrum. So we would like it to be minus 1.5. So what do we do then? Well, I think we should change this value here. Yes. But then we of course also need to change the other value. Yes. So we change this value to something like 16 or something, which is closest possible enough. And then we change this back to 1, and we see if it's close enough still. 6, 7. So we could keep going here. Okay. As long as we are in some kind of range here, it's good. I mean, I'm not a professional. I'm just a hobby nerd, So we are still getting a large value. So how do we get it to become less large? We have to decrease. But what's going to happen when we are trying to get a positive voltage? Yeah, I don't know. We will just have to see, Well, we are getting a value which is positive at least. If we compare here, it was positive 5.9. And now it is not really that large. So if we say that we are here, we are choosing a value from here to here, which is divided between this voltage divider, consisting out of these two. So that's the first value we choose, and then we choose the amplification, which is something between this and that somehow, that I'm not sure how to calculate, but so we will just have to guess a little bit more, I think. So we want this to be a little bit larger. What do we do? Well, we could decrease this value a little bit, maybe. No, it was shrinking, so we increase it. Yes, we increase it a little bit. Yes. How much is that little bit? I don't know. We will have to test to see. So we want somewhere, yes, somewhere there. So, and this should be a negative value. which we want to be a little bit larger. I think I will do like this because it's faster. So this is 10 and this is 90. So we can just switch between them, very quickly. And we want to have this to be somewhere here, 5, 6 something, and the other one should be -9 something. So we could also change this value right here. There is also a possibility to do that. But if I change this value just to 33, yes, beautiful, and then we check it, what is it doing on the other end. It's a little bit too large, so we just decrease here. I don't remember which it was. So, okay, so let's just say middle way 30 here. Okay. Okay, so it's sort of there and sort of. Well, at least it's both larger and larger. So we take this one and we take it 30 also. Maybe this would also be good. So that's very good. Let's settle on this values. Just write something here. Okay, and yes, can we please stop this now because it's eating away on my computer's power. Okay, beautiful, isn't that beautiful? And here we write, what do we write here? We write original. Original for 24 plus 24 plus 24 plus 6 minus 10. Okay. Yes, and then we insert these values in the easy EDA sketch. So let's say this was 30, 30, and this is also 30. Yes, anything more is changed? No, that's it. That's it. Okay, beautiful, beautiful. So now the next problem is I want something that can give me the possibility to change these points here so I can check several different tubes so the grid will not be on the same pin in every one of the things. So how do we do that? Most simply, Yes, I think actually the most simple way would be to use banana jacks here. So then we will have banana holes here called A, G, C. So we have 3 holes here. 1, 2, 3. I wonder if there is such a thing as banana holes. Let's see. Banana hole. Yes, I think so. Let's see. Banana hole. Yes, very good. Library is contributed. So it's, let's see. User contributed. Banana jack hole, banana hole, banana hole, banana hole. There are so many banana holes. I will just check my bananas. How large are they actually? So we don't make a mistake. So my banana are 4 millimeters bananas. So yes, 4 millimeters bananas. PCB banana. No, not really. Banana hole, banana jack print, banana, 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 banana. There are so many bananas here, so I'm going bananas. Banana 1. Alright, let's just use this. Did I actually delete everything? No, I didn't do that. So, okay, banana. No, I wanted to put it right there. Banana, yes. Place banana. 1, 2, and 3. Okay, so what do we do? Let's see, how do we do? Yes, we do like this. Let's see. Okay. Then let's call it banana G. And this one is called banana A. Banana A. And banana C. Not sure if we're gonna need this right now, but you never know. And then we have, our pins. So how do we do that? Well, we do like this. We take the copy of this and we make it so that it is called banana pin 1. Okay, 5. What did? No. What you tried to do with me? All right. So 5. Stop doing that. So I will start. What is it trying to do there? It's doing something automatically now. When you have a cable that is lying on your pad and your touchpad, it starts to act like an individual. Okay, yes, I was trying to say that I will start with 9 pin only, and then we might add a second one. So let's see, how are we actually doing this? Do we have to have I'm trying to think now, but it's not easy. It's definitely not easy. Yes, but we will have. Okay, where are we here? So here we are. Okay, so we are here and we are getting a voltage that's coming from the anode to the cathode. Okay, very interesting. No, not interesting at all, but just irritating. Okay, so I think that I'm just made a little bit of mistake here. Instead, let's see here. Yes, I think it's gonna be like this. That this is going to be over here, and this is going to be over here, and this is going to be over here, and the here is only going to be the actual this thing. Yes, this thing right here. And that means we have to make 9 new nets. And then we take one cable from the left and put it into a banana jacks on the socket, and on the right side we take two cables and we take them to 2 pins on the banana jacks on the socket. That will be very good. So then we could just simply start here by making the nets, which will be called just maybe pin 1, and so on, pin 2, pin 3, pin 4, pin 5. Oh my god, it's like riding a roller coaster, this. 7, 8, 9. And then we start from the beginning again. But does this actually have any points that I need to be aware of that are invisible? Yes, they are invisible. No, they are now visible. Okay, good. Yes, beautiful. Let's see. Nope. No more automatics, unfortunately. So let's just do what exactly? Just copy everyone. Yes, very good. C and V. Excuse me. Okie dokie. Okay. There's some problem with the grid. Okay. Okay, so we have something going on here. Something. Now let's just test if everyone is connected by moving them slightly around and see if the line is following them. Yes, it is. So beautiful. Then we can move this out of sight down here. If you want to, you can make it look good, but I don't gonna care about that because I don't have so much energy today. Let's just make this a little bit larger here. And let's see how to do that. Yes, A3. Beautiful. So now we are closing in, we might say, to this thing. Did I save this? No, I didn't save it yet. So let's save it, put it in the correct folder, and just call it simulation. And there we go. That is ready. So next step is to do what exactly? Well, I don't know. Yes, look at the... Yes, this part is actually quite simple. So we have some kind of incoming voltage. No, what are you doing? Okay, so let's just copy this here. Yes. No, wait a minute. Where are we actually now? Okay, I'm getting confused. And I feel it's time for a break. Okay, 33, but just try to finish it. So 33, 33, yes. And banana. Do we even need this anymore? I don't. Yeah, we could keep it. No, let's just throw it away. Okay, we still have the banana. And the banana is now our official net flags. Okay, so it really doesn't want to work today, but who is caring? No, I'm not caring. Are you caring? No, I don't care. Da do da do da do da do da do. Okay, so the only thing now is this little voltage divider right here, which looks very precisely chosen. Why? I have no idea. But we can... well, it's probably, if I say probably chosen, because the person who made it wanted to get a voltage that is between 0 and 5. Yes, most likely. So, how do we get that? Yes, we do like this. So take a voltage that is 24. Okay, yes. And then we take a resistor that is 33, 33, and then we take a resistor that is 1470. Okay, and then we take a forget 330 resistor. Yes, 330. Okay, and then we take a ground, and then we look at. We could take a voltage meter like that. So we are getting a 4.321. And if we try this with my setup, let's see what values we will be getting. And these values are 12. And here we have negative 12. Negative 12, like that. So now we just adjust these values here until we get something similar to that right here. So if we would we could start by taking one mega from here and putting it here and see what happens. Let's see what happens. Well, we are still too large. So what happens if we just go back, and we simply switch places between these? What will happen? The excitement is exciting. Oh no, that's even worse. So what do we do? What do we do? Yes, what do we need? What do we need to get this to work right here? What would we need to get it to work? Very interesting. Very, very interesting dilemma. No, I actually think it's a very stupid dilemma, but who cares? Okay. Let's take 560 here and 830 here. What do we get? Yes. And then we just very slightly decrease the value here and see what happens. Okay, we can increase the value then. Increase. Yes. And if we decrease this value, okay, let's see. But what is it actually that I'm trying to do, Because there will come a signal here, and that is the thing that we need to consider, I think, So we are having an input voltage. We could call it voltage source right here. And this will be something, I don't know. But check how does it affect. So let's print this in a graph, and this one as well, because it's not just about Yes, we need these two waves here to become the same. So how do we do that? Yes, very interesting dilemma, my dear Paradon. But it's not actually. Is it really supposed to do that? That's very, very, very interesting. Maybe we have to put a little resistor here or something, just because, for the sake of it. I'm not an expert in this kind of things, but I would expect that we would need something like that right there. Okay. So let's see. So this one is way too deeply downward. But you know what? What if we would take this away and instead we put a ground there? I mean, it's still the same thing that is going on, right? Yeah, I think so. And then we re-switch back these, sort of like it was before. And let's see what happens. Yes, but we need that to be attached. Oh, you see how close that is? That is beautiful. So then we might actually just use the same values here and get away with it. Sort of, sort of. We're actually getting a negative value. How is that even possible, I don't know. Well, it's because ours is sucking vacuum, sort of. Yeah. So ours is sucking vacuum, which is something very interesting. But what if we increase this value right here? Could we do that? Nope, that will only increase the fluctuation and not the bias current. So what do we do then? Well, we have to increase or decrease this one right here. Yes. Oh, I'm so smart. We should divide it by 2. Yes. Very good, young Padawan. You're a genius. So, I'm a genius, they say. And then we need to very slightly increase the amplification, and that's about as close as we're going to get it. I can tell you that. So let's go with these values right here. We could actually test it without that resistor because I don't know actually what it does, but let's test it. And we are sort of, it's a little bit different, but we could easily, yeah, that's actually exactly. So let's go with this setup right here. So the only thing we have to do is divide this by 2. So divide by 2, and these are the same, and this is actually ground. So where were we? Here, yes. So let's see now. We have to be a little bit smart here. This is going to stay like this. But we need to get a ground from somewhere. And where do we get a ground? What does that ground actually mean? Does that ground mean ground here? Or ground here? That is the phenomenal question. So we will have to keep this one right here. So that will be the negative bias right there. And then we will have this one right here. And we will have some resistors here, just like this. One here and then another one like there. And then this one should go up here. And then this one should be the very specific value of I will not care about that. So let's just do it like this and put this one at 330 like that. And then we have to get a outgoing signal right here. And let's see, where do we go with that one? Well, it goes to A5. A5, so beautiful. And let's copy A5, put it in, guess what? A5. And let's see what more we have in the original schematic. So let's make some drawing here, because we have to show the world that we have created something beautiful. Okay, you see, so we connected this, 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 and this, and yes, that one there. So okay, so let's see here, ground and ground. So you connect ground to ground. You are such a nice drawer. Alright, so I'm going to ignore that specific ground to ground here, because I am so quick and dirty. So we just take this one right here and we connect ground to ground, and then we take D12 to a pull down resistor, but I don't like 1K here because that will drain something quite quickly. No, wait a minute, it's pulling it down. So, but I still gonna use a larger value here, even though it doesn't care. But you can never care too much. Why is this having, what is that, MH? Well, I don't know. Okay, so let's just put a ground. No, wait a minute. We should put it here, and then we take this like this, and we put it there, and we put it there, and we make sure everything is following everything else like this. And we could have a number. Why not 100, and then sort of like this, and then a button here. So do I have a push button in my sort of here thing here? Tactile push button switch. I have no idea if I do, so we might as well just go straight to the library and we can write 6mm tactile. Yes, we get 100,000 of them, but we want it to be not SMT, but you know, this kind, but with 2 holes. Where is that? Yes, actually we got it. The last of the ever possible ones. Beautiful. So let's just, no, yes, no, okay, beautiful. So just like that, and just like this, because we can, and it doesn't cost us anything, and we call this button. Is it called button or button? I don't know. That's called button. Yes, 6mm. Yes, very good. All right. So that the switch is there, and this one is there, and this one is already there, and yes, 5 volts and ground to. Well, let's just connect the ground to ground now, won't we? Oh, wait a minute. Yes, but we can do it like very simple, just like this. We don't have to overdo it. Just like that. And yeah, we could actually attach the voltage here. Yeah, we could power the Arduino right here as well. Or did we have to? Yeah, the guy said we have to have it in a serial connection to the PC. So, alright. What does this do over here? So I think we're done. So then we have save, and then we are sort of ending this part. So remember, who is making it is Mr. Nerding and Hoarding, and it is the 12 volt minus 12 volt vacuum tube tester with Arduino. And yeah, and it has the factory batch number 0070. Okay, file save a file. See you later, alligator.